All right, so this is the free response that was assigned yesterday on pages 110 and 111. So we're going to go over those, and then again for homework today I want you to do pages 86 and 87. Those are in your packet. They're out of order, but they're in your packet. They are. Just go find them. All right, so here we go. This was the problem where we've got traveling an average of 125. Okay, so we know that that's our mean for the population of all of these cars. We know that the stopping distances are approximately normally distributed. The standard deviation is 6.5. So first question is, what is the 70th percentile for stopping distances? Okay, so I know that I had to do inverse norm of the area below. Is the z at that spot? So in order to get that z-score there, I did inverse norm of my 0.70, and I got 0.5244. So I used this in my z-score formula. This formula is actually very critical to you getting credit on this part of the exam because it identifies the parameters, and they specify that in the grading guidelines that has to be specified. So this distance at the 70th percentile is 128.41 feet. Now let me go over how that has to be scored. So in order to get credit on this, you had to indicate the distribution shape and the parameters, meaning the mean of x and the standard deviation of x, and then have the correct calculations. So I feel that you would probably do this mean of x and this standard deviation of x if you filled in the formula. Look at these notes here. It says the standard, the z-score formula setup implies the distribution and the parameters. So that is huge, meaning that the fact that you put this z-score formula implied that you were saying this was normally distributed, and it implied what your mean of x and your standard deviation of x. So that covered 2 out of the 3 requirements to be essentially correct. So you have to show that. And then you have your answer there. So if you showed this z-score formula setup and you showed your answer here, you got essentially correct. If you had one of those items missing, then you got probably correct. And if you missed more than 2 of those items, you got completely incorrect. It goes in here, and by the way, it gives notes saying things like the inverse norm command provided. Okay, if you wrote down inverse norm of 0.70 and then you just gave your answer, okay, but they give different things here than we do. So that it's the calculator speak is just not good to give you information, because not only would you have to have given this, but you would have had to had an appropriate labeled normal model sketch. So we just need to go with the z-score setup to get full credit on that. All right, moving on. What's the probability that at least 2 cars out of 5 randomly selected cars will stop at a distance greater than that distance calculated in Part A? So a lot of you, could follow that this at least 2 out of the 5 cars, you understood that to be a binomial calculation, because if you have 0, 1, 2, 3, 4, or 5 cars, and by the way, it's binomial is appropriate because you can't have a part of a car, so it's not ideal to calculate this with a normal approximation necessarily. See, feet is appropriate to be in a normal distribution because that is a continuous value. But number of cars is not. That's a discrete amount. So it's more appropriate to be binomial on this, by the way. All right, so we want at least 2. So here is what I want. And here's what I do not want. All right, so work-wise, you could show the 2 up to 5 in your sequence, or you could do 1 minus, and you could show the 0 and the 1 that you are taking off. So calculator-wise, see this part, the 0 successes and the 1 success that get taken off are binomial CDF of 5.3, 1. Now, people were asking me, what is the P? What's the probability of success? Well, here's the deal. Okay, right up above here, it told you that this distance, 128.41, was above 70% of the data. So, what's the probability that you will stop at a greater distance than that? Is 30%. So the probability of success was 30. Okay, so that was the key that you did need to catch to be able to do this problem. All right, so then once you did that, okay, credit on this one, part B. It's essentially correct if you represented this as a binomial and you set up the problem correctly. So you had to give that formula. If all you had was this calculator command of 1 minus binomial CDF and the answer, then that is going to be scored partially correct because you haven't indicated that it's a binomial distribution. You would have to give the correct formula. That's why I'm telling you that this formula has to be there in some regard, whether you did 2 to 5 or 1 minus 0 and 1. The formula has to be there to denote binomial distribution. All right, so you get E if you had the formula and the work. You get P if you just did one of those things, just the calculator speak. What's the probability that a randomly selected sample of 5? So here's the thing. This problem is now talking about samples of size 5. That's a sampling distribution now, not the population. Up here, our standard deviation was from the population, and it was 6.5. But down here, we have a sampling distribution of samples of size 5. So guess what? That's this. A sampling distribution of sample means with samples of size 5. So our standard deviation that we use on this one is not 6.5, but 6.5 divided by the square root of 5. Okay? They also required that you notated that it was normal model, and I bet you having this right here would indicate that normal. We'll check. We'll look at the grading guidelines again. And then you norm CDF'd that so that your probability was 0.0427 or 4.27%. Let's check what you had to have to get that one full credit. So here we go. Part C, it's essentially correct if the student recognizes that the distribution of the sample means, so the shape of it, the sampling distribution is approximately normal with the mean and correct mean and standard deviations. There are 3 components. You had to give that distribution shape, say what distribution it is, the parameters, that's the mean of the x-bar and the standard deviation of the x-bar and the calculations. So let's look at the notes. The z-score formula setup suffices, oh, look at this, this is interesting, only for the parameters, meaning you had to have your conditions. Whoa, okay, that probably caught a lot of you off guard. It might have even caught me off guard when I did it the first time. So the z-score formula counts as your parameter, but not as your conditions to describe that the sampling distribution is normal. So that's an issue. So if on this case you did not give the random, independent, and large enough, it's not large enough, but it stated that it's approximately normal and clarified that this distribution is approximately normal, then you got a P. So isn't that interesting how they said the z-score formula counted as distribution also on part A, but not on part C. And here, in a nutshell, is why. This, part A, is about the population. The population was stated to be approximately normally distributed, so they weren't as strict on that. However, this is a different distribution. This is the sampling distribution, that drop-down sampling distribution. So you have to make a concerted effort to tell the grader this is also normally distributed. All right, so you can say count your E's and your P's, and let's see how that gets scored. You get a 4 if you get all 3 E's. You get a 3 if you get 2 E's and a P. You get 2 if you get several things. Let's see. 2 E's and an I. E, PP, and PPP. I bet, let's see here. I bet EPI would count for this also. Okay, and then 1 point if you got an EII and or PPI. All right, so there's your points on that. Hopefully you got some stuff there. Okay, page 111. Here we go. So this here is big enough that it is going to be giving us the probability of getting a part E. So the first thing, I've got really too much written out here. I think part A could be done simpler. First of all, the probability, first you had to get a probability for E. Okay, and to get that probability for part E, you were doing this 2323 over the total population of 297,354, and that is a very small proportion, that is 0.0078. All right, then look, it says this: find the expected number and the standard deviation. So guys, get this in your mind. Expected number is the mean. So get expected number and standard deviation for the number of owners in this sample of 2,000. So formula, chart this mean and this standard deviation for the number of owners in the sample of 2,000. So your N is 2,000 and your P is that P you just found. And then you're filling in these two formulas to get the mean and the standard deviation. All right, so there's part A. Let's see here. So let's see, grading-wise on that real quick. We've got E if the calculation of the expected number showing the proper method for the calculation and providing the correct numerical value. So you had to get the correct method, probably meaning like showing the formula, not just putting the answer down. You had to show your two numbers that you multiplied together to get the expected value and the standard deviation. All right. Partially correct if you only got one of those two items, or you display correct formulas, but you failed to show the correct numerical values. So if you don't put the numerical values into the formula and show that, you wouldn't have gotten back credit. Okay, part B. Part B now says, when selecting a simple random sample of 2,000, how likely is it that fewer than 12 owners? Okay, so you can do this one of two ways. You can do this with the normal approximation. So fewer than 12. So I did a z-score where 12 is my x, and then there's my mean and my standard deviation from before. Okay, and so then I get, for the normal approximation, norm CDF below that, and I get about 17.98%. Okay, carefully, since this is talking about number of owners And that's a discrete amount. You know, you're not going to have a part of an owner. I really do think that the binomial method is better. And so I'm going to show that to you real quickly. Basically, let me go ahead and write that out, and then I'll show that to you. Okay, so here's that binomial method shown to you. Here's the work shown. You went from 0 successes up to 11 successes because it has to be fewer than 12. So here's the work. Here's my sequence from 0 successes. See, in this probability there were 0 of them, and not happening, there were 2,000 of them, and so on. And then on this one, this probability, 11 of them, and the not probability, there were 1989 of them. Okay, because keep in mind, you know that these two numbers here total up to 2,000. All right, so that's the work that would be shown if you were to write out the formula, but the calculation in the calculator I would do would be binomial CDF of the 2,000 with this probability up to and including 11, and that comes up to 0.147. Now keep in mind, my normal approximation is bigger than the binomial approximation because mine includes like all the itty bitty little parts in between, the 11.1 and 11.2 and 11.333 and 11.444897 and so on. So my normal approximation is a little bit bigger. They accept either. So let's look at the grading guidelines. They say on part B, it's essentially correct. You recognize that it can be the normal distribution, identify the correct parameters, and sets up the probability and calculates correctly. Or you can use the normal probability approximation by identifying the mean and standard deviation, and you show the correct probability. So your formulas here, we're going to go with having done that. Let's see here. Let's see, if the parameter values were properly identified in part A, they do not have to be identified again in part B. If the response shows a correct calculation, but no about the likeliness is necessary, let's see here. Okay. With the normal calculation, they're saying it's acceptable that your X value is 11, 11.5, or 12. Okay. All right, so there is your credit on that. And so now let's go over to part C. And so the final thing says, you know, they are concerned that a sample of 2,000 would include fewer than 12 owners of model D or fewer than 12 owners of model E because those were such small probabilities. Describe how you might sample so that you can ensure that you will have at least 12 owners. So here's how I said that I want to do this proportionately to what is in the population. So I will stratify by type of car, okay, and then within each strata, I will put the owners' names in a bag, I will shake well, and I will pull out the expected number of car owners of that type. And so then I rounded these expected numbers. These expected numbers came from the probabilities of those happening. So let's see what they required of you to say. Essentially correct if the response describes an appropriate sampling method and ensures that you will have a total sample of 2,000, that at least 12 owners for each type will be achieved, and that they are randomly selected. So I put them in a bag, I shook well. So if you did all three of those things, you get E. If you just have one or two of those things, you get a P, and if you only have one of those things, you get an I. So here are your ways that there were three parts to this. Again, EEE is a 4, EEP is a 3. Let's see, EEI is a 2, EPP is a 2, and PPP is also a 2. I would also say EPI is also a 2. And then here, EII is a 1, or PPI is a 1, and anything less than that, you got no credit. All right, so I hope that we're getting better, or at least you're having exposure to more kinds of problems. It's so important that we keep practicing this, and you see how those grading guidelines are counting for you to get full credit. So again, homework, pages 86 and 87.